How do you teach math and science in a classical approach? That's part of what I'll be talking about in this video. This will also serve as an introductory module using the approach that I'm going to be talking about. My name is Amos Tarfa, and I am a medical physicist based in Texas. I grew up in Nigeria, came to America for my bachelor's degree in chemistry, pre-med. So I was going to go to medical school to be a pediatrician. That's a story for another day. I ended up moving towards the academic route. I got the opportunity to teach at a private school in Duluth, Minnesota. I taught for 2 years, and then I started a tutoring center. So I've worked with students from various schools over the past about 12 years in different ways. Even while I was still at Lakeview Christian Academy, I had some students that I worked with who were attending different schools, like in the summertime especially. I'm always a fan of learning in the summer. But in this video, I'm going to talk to you about, again, this classical approach to teaching math and science. I've written a math curriculum now for about 12 years. I have a curriculum called Counting to Calculus that takes you from basic math all the way to calculus. There's a video that you can find on that on our YouTube channel called Counting to Calculus. And then I have a channel called Living Sensibly with Amos Tarfa, where I talk about life and faith, apologetics. And so you can join me on any of those channels. But in this video, let's talk about a classical approach to learning math and science. Well, the thing that is very interesting in the day and age that we live in is that information is everywhere. That's not the issue. The problem is that many people are not, many students are not excited necessarily to learn about the content that we're giving them. So it could be that our approach to education needs to be revised. Number one, information is everywhere. So maybe we should take a step back and ask, how can we inspire students to love the material that they're learning? The effort needs to be put in to become good at anything. And sometimes people will not put in the effort if they don't see the benefit or the point. And part of what I believe this curriculum can do is to help students to see the point. Rather than telling a student to just learn Newton's law of gravitation, what if we explain the context in which he came into that gave rise to the equations that he worked on? The book Journey Through Genius is one of the books that we use with our students, and it tells the story of Isaac Newton. There's another book here called The World of Isaac Newton that I'm going to be reading. I got it when I visited his house in Woolsthorpe in England, which is part of this classical approach, right? I want to understand, okay, what was the world that you were born into, right? Newton was born during a very tumultuous time in England, by the way. It's very interesting that even in the midst of that, he was still able to make great gains. Same with Euler, which we'll talk about Euler and Newton as we go on. But I believe that we need to help students to see the point. Why are they learning what they're learning? What is the historical context that gave rise to the discoveries? What was the thing that kept them up at night that made them to do the work that they did? That's the approach that we're using. So in our Counting to Calculus framework, we want students to master mathematics quickly using a book like this called Understanding Mathematics from Counting to Calculus. We want them to master mathematics, but we want to connect it to physics and chemistry. I'm going to read you a quote that would lay the groundwork for more of our discussion on the historical perspective to math and science. There's a gentleman called James Clerk Maxwell. A lot of my friends know when I mention that. I mean, when I'm giving a talk, most people can guess that I'm probably going to mention his name somewhere. And I love Maxwell and Faraday. Those guys were humble and they were hardworking and they were exceptional. Maxwell is the greatest mathematical physicist pretty much of the 1800s. This is a paper about Maxwell and Faraday called The Genius and Faith of Faraday and Maxwell, written by Professor Hutchinson out of MIT. We're going to talk more about this paper in a different video, but let me read you a quote from Maxwell himself in his inaugural lecture at King's College London. This is from 1860, which is interesting because this is a year after Darwin, by the way. We'll discuss that too, but we're going to learn science more from a historical perspective, moving back in time to the ancient times. We're going to start from the days of Abraham all the way to about 100 AD, and then we're going to take things from about 100 AD all the way till the printing press and the Copernican revolution of happening. And then we're going to go from that period all the way to the present. So 3 periods of time. We're going to follow a similar program to what Veritas provides, where there's a primary 1, 2, 3 and a secondary 1, 2, 3. And we infuse that, like we take that same project where they have 6 years and we put it into a narrative of the history and philosophy of science. Of course, the philosophy of science will come in the later years. But let's get back to work now to talk about Maxwell. And then we'll talk more about, if you have questions about, like, how does this work or why are we doing this, I'm going to make videos about that. However, I'm also going to make videos where I'm actually instructing using a classical approach. This is like a dream come true. Imagine a teacher walking into the classroom and reading the works of Maxwell and reading the works of Faraday and reading the works of Euler and Newton and Gauss to the students and helping the students interact with these masters of mathematics. Let's listen to what Maxwell said, just to give you an idea of how Maxwell wrote. Maxwell said, if we require to make up our minds as to the relation of natural philosophy to other branches of knowledge, to our own education, or to the progress of mankind, we must do it today. For tomorrow, our business will not be about natural philosophy, but will be natural philosophy itself. I'm going to fast forward later on. He says, natural philosophy is bounded on the mechanical side by mathematics and on the physical side by chemistry. Mechanics differs from mathematics only by involving the ideas of matter, time, and force, in addition to those of quantity and space. The methods employed are the same as in mathematics, and the axioms or laws of motion upon which the science is founded are of the same kind as those of geometry. Chemistry, the science which bounds us on the opposite or physical side, investigates those properties of matter by which one substance is distinguished from another, and it contemplates these substances as differing not merely in the degree in which they produce similar effects, but in kind, in their very essence. Maxwell is an interesting guy. He's talking about natural philosophy, and there's a field called natural theology, which we could talk about as well later. But he's talking about natural philosophy, which is what they used to call science back in the day. People like Newton would be called a natural philosopher. And so he says that it's bound by, there's the mathematics and there's the chemistry. Now, Maxwell himself would be considered a physicist. The three greatest physicists ever are actually Einstein, Maxwell, and Newton. So Maxwell says this, and here's what's fascinating about his resume. Do you know that the kinetic theory of matter, that idea partly comes back to Maxwell? And do you know that there's things called Maxwell's equations that explain things that Faraday had done? And so you have physics there. So Maxwell is in physics, Maxwell is in chemistry, Maxwell is using mathematics. Notice how versatile Maxwell is. But also Maxwell has some knowledge of philosophy, moral philosophy. That was part of what he had to teach at one point in his career. We need people, or we want to raise the next generation of top scientists who are who know and master the sciences and philosophy. But so basically, we want to raise the next generation of top scientists who are good in science and mathematics and so on, but they're also good at logic, philosophy, and theology. We want to see people like Maxwell again, people that are able to take knowledge from one field and apply it to another field. That integrative approach is what I'm looking for. That's what this classical approach is about. It's about integrating chemistry and physics as they can be integrated in physical chemistry. For example, when you talk about things like gas laws, you're integrating chemistry and physics. But it's also talking about how you can allow people to interact with some of the masters of math, chemistry, and physics. Copernicus, Galileo, Kepler, Newton, Euler, Gauss, Maxwell, Faraday, Einstein, Dirac, J.J. Thomson, Feynman. These are just some examples. Do students know who these people are and what they did with the opportunities that they were given in math and science? Now, not all of these people were good in theology, and not all of these people were professing believers, but a lot of these people were professing believers, and they made a great impact in the field of science and mathematics. I would love to see a generation of exceptional scientists that are seeking to lift high the name of Jesus, to glorify God. As the Bible says, the heavens declare the glory of God. And we see that with Maxwell, we see that with Faraday. And you might not know this, but when it comes to the greatest inventions of all time, I was talking with my wife recently about this. I think that two things are up there consistently. I would say batteries and electricity, right? These are huge in how we live our lives every day. But did you know that Faraday and Maxwell we can explain a lot of these things back to these two men? And listen to the title of this paper that I mentioned earlier, The Genius and Faith of Faraday and Maxwell. Before we dive into them specifically, let's take a step back and look at history. When you go back to the days of Abraham, you have to look at what were the civilizations up to. We talk about the Egyptians and the Nile and understanding the pattern there of the river rising and so on. We talk about the Babylonians. We talk about Mesopotamia. Yes, there was science and mathematics in some way there, but one of the oldest fields of science is astronomy. When you go back, you notice that astronomy is what actually drove a lot of the work that a lot of these people did. Like, really think about it. Copernicus, astronomer. Galileo, astronomer. Kepler, astronomer. Newton, astronomer, mathematician, and physicist. Euler, writing some math equations that help us understand astronomy. On and on and on. Isn't it interesting that the heavens which God created opportunities for people to study it, and by studying it, they became exceptional in mathematics and physics and so on. But then we found applications in mathematics, physics, and so on that has now driven us into more advanced work that we do today. But it all goes back to the heavens declare the glory of God. And it all goes back to in the beginning, God created the heavens and the earth. Science owes everything back to the one who created it. There's a book by John Lennox called Can Science Explain Everything? I recommend that you read it along in this class. And he does an exceptional job of explaining the limits of science. Why should we teach science and math from a classical perspective? Because it will help us to understand the limits of science. It will help us understand the historical context. And it will help us interact with some of the top minds that have ever lived. Welcome to STEM Excellence, the science and math curriculum that will guide students from a classical approach, looking at primary documents of Euclid and Euler and Maxwell and Faraday and so on and so forth. And eventually our goal is to have more of these field trips where we go to the Cavendish Laboratory in Cambridge University, where we go to the Royal Institution in London, where we go to Princeton University, the Institute for Advanced Studies, and we study some of the works of some of these top scientists, mathematicians, and thinkers. So those are some things for you to think about. The time has come. We're ready to launch into this. And so now I will step in and give you a lecture from a classical perspective. Thank you for watching.